All right, here we go. So let's see. Today we're talking 6.3 triangle medians and the centroid. So this is going to be our third special triangle segment. And this is the first one that's actually kind of brand new to us because our first couple were the perpendicular bisector and the angle bisector. And those we had kind of talked about in chapter 1 a bit, just not as specifically as they pertain to triangles. So today this is a brand new one, a median in a triangle, and it is a segment that goes from a vertex to the midpoint of the opposite side. All right, so in this picture right here, we see 3 medians, one that goes from this vertex B to the middle of the opposite side. You can see that it's marked as the middle because these 2 segments are equal. Then we've also got this one that goes from the vertex A to the middle of this side, and then from the vertex C to the middle of this side. And so just like with angle and perpendicular bisectors, in that they all intersected at one spot, these also all intersect at one spot, and that point is called the centroid for our triangle. So just like those other ones with the circumcenter and the incenter had a theorem and properties that went with them. Same thing with the centroid. So the centroid theorem says that the centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. So 2/3 of the way down the median, you get to the centroid. So what that means in this picture is that if this is one of our medians, and this is the centroid, this distance right here from the corner to the centroid is 2/3 of the total distance or of the total length of the median, which then means that the rest of this is 1/3. So we have this 2/3, 1/3 relationship going on here. And we can use that to find missing measures. Like if I knew that this whole thing is 9, then this part would be 3 because that's 1/3 of 9, and this part would be 6. So we have this 6, 3, whole thing is 9. That's the kind of relationship we have here. Or if this was 3, then the 2/3 part would be 2, the 1/3 part would be 1. So that's what we're going to kind of start using here in this example down here, the first example. So we're told that Rx is 48. So we're just going to start with that. Rx is this median, and it's the full length of the median that is 48. So what we want to do in this first one is find Rw. Rw is this length right here, and this is the 2/3 piece. So if this is 2/3 of the whole thing, one way you can find 2/3 is go 48 times 2/3. And you can do that in a calculator. You can do that by hand. Either way, you should get 48 times 2/3 is 32. So that means that Rw is 32. Another way that you could do it is that you could take 48 and divide it by 3, which gets you 16. And then since 16 is 1/3, because 48 divided by 3 gives you thirds, you could take 16 times 2, which will get you 2/3. Either way you want to think of it is totally fine. So that's how you'd find Rw. And then the other one that we want to find is Wx. And Wx represents this other portion over here, the 1/3 part. So there's a couple of ways you could find Wx. One that you could do is you could go 48 times 1/3, or 48 divided by 3. That would be the same thing. And then you would get 16. So Wx is 16. The other thing you could do, though, is since that you know that the whole thing is 48, and we just figured out that the 2/3 part was 32, you could go 48 minus 32 to get the remaining part, which would be 16. So either way you want to do that is totally fine. You should get the same answer either way. All right, so that's what you do if you're given the full length. and you want to find just the 2/3 part and the 1/3 part, and you want to split it up like that. All right, but what if you're given something else? Well, that's the QW case right here. QW, just this part, is 30. And QW is the 2/3 portion of QZ. So if you have the 2/3 part, well, what if I wanted to find the 1/3 part here? And I have 2/3. You just cut it in half. Because if you take 2/3 and divide it by 2, you get 1/3. So the 1/3 part here would be 15. So that means that WZ is 15. I know we skipped this one. We're going to come back to it. And we just found that by taking the 2/3 portion, which was 30, and dividing it by 2. All right. And then to find QZ, the whole thing, you just take those two and add them up. 30 plus 15 gives you 45. And there's other ways you could find that as well. For example, if you knew that WZ was 15 and that's 1/3, you could multiply it by 3 to get 45, which would be 3/3. Or you could take 30 and multiply it by 3/2 and get 45 as well. But this way seems easiest to me. You can do it whatever way works for you, but I like this way. Okay, so the next section down here is the same kind of problem. So take a couple minutes, pause the video for a sec, try these 4 on your own. They follow the exact same pattern that the first 4 did. Label on your picture the things that you're given. Figure out if you're, multiplying by 2/3 or 1/3, or if you're dividing it by 2, depending on whatever you have. And then unpause the video and come back and we will go over these. All right, so hopefully you did that. If you didn't, we're going to go over how to do these problems. So I recommend pausing it and trying them first. But let's see what we get here. HD is 21. Here's HD. HD is a full length of a median. I'm looking for HB and then BD. So both of these, this is the 2/3 and the 1/3. So this is just like the first 2 that we did up here. So for HB, since HB is the 2/3 part, I'm going to go 21 times 2/3, which should give you 14. And then you can either go 21 minus 14, or you could go 21 times 1/3 to get the remaining part. Either way, you should get that this is 7. So we broke this up into 14 and 7. Then we're also told that BK is 18. BK is right here. BK is the 2/3 portion of this whole thing. So if BK is the 2/3 portion, that means if I take 18 and divide it by 2, that gives me a 1/3 portion. So this part, BC or CB, would be 9. And then if you add those together, you get the whole thing. 18 plus 9 is 27. So CK, the whole thing, is 27. All right. So that's most of what we need to know concerning the centroid theorem. So we're figuring out what 1/3 or 2/3 or a whole thing will end up being. The last thing we need to talk about on this page is the altitude of a triangle. Now, we're going to get a lot more into altitude later on when we talk about triangle area and stuff like that. But for now, what do you think of when you think of altitude? You might think of an airplane cruising at a certain altitude, or a mountain, or altitude sickness if you're climbing a mountain. Or you might think of height. And in general, height is what we want to think about for triangles with altitude. An altitude of a triangle is a perpendicular segment that goes through one of the vertices to the opposite side. And it should be straight down is what we're thinking of here. Because if you think about it, if you're measuring your height, you're not leaning over to measure it. or you're not measuring from the top of your head to a point over on the floor somewhere, diagonally. You're measuring straight down. And same holds true for triangle height. So we want to go straight down perpendicular. Now, occasionally there's a triangle where you can't quite do that within the triangle. So like if I have this obtuse triangle over here and I start at point Q, I can't draw something that goes from Q over to PR that's perpendicular. So in this case, you do have to extend that PR side a little bit, and then you can drop a line straight down. And that's okay. This would be considered the altitude with this obtuse triangle. So in order to recognize an altitude, it needs two things. It needs to go through the corner, and it needs to be perpendicular to the opposite side. And that's all we're going to do with altitudes for the moment. We'll get more into those later. Okay, so the homework, for those of you who have me in class, if we turn the page, oops, that's the key to the homework. We're going to jump to the first period packet instead. I know as much as you would like to see the key now. Here we go, the homework. In the first four problems, you're given QN, which is the full distance, and you need to find PN and QP. Those are the 2/3 and the 1/3 portion. In 7, 8, 9, and 10, you need to, you're given DE, which is the 1/3 portion, and you need to find the 2/3 and the whole thing. Down here in 11 through 14, you're given a couple of measurements, 6 and 12. These are already marked in the picture. You also know that this is the centroid. But notice AE, the other measurement they give you, is not already pre-labeled for you, so you need to mark that one for yourself. And then find the missing measures that are right here. Then on the next page, more of the same kind of thing going through these, but I want to draw our attention down here to number 5, and actually 5, 6, and then 15 through 17. This is finding the coordinates of the centroid of the triangle with given vertices. So it's possible to do this by graphing. So that's what we're going to do real quick here. The coordinates of this are, for the first one, I'm going to flip it over actually, because you might notice on the next page, there's a graphing space. So for number 5, let me see, what were the coordinates? So you want to label it number 5. The coordinates were -2, 6, 4, 0, and 10, 6. So in order to find the centroid by graphing, first you got to graph the triangle. So over -2, up 6. That was 6, right? Yes. And then over 4, up 0. And then over 10, 6, 8, 10, up 6. And I recommend using a straight edge here because it's going to make your life a little bit easier when it comes to finding the medians and stuff like that. So I'm going to use my straight edge to draw my triangle. If you don't have a ruler, just find anything else that is flat and straight that you can use to draw your triangle. Okay, so there's my triangle. And what we want to do is draw the medians. So to draw the medians, you need to find the midpoint of all of your sides. So to find the midpoint, you could use the midpoint formula. But since I'm doing this on paper already, I might as well just kind of count and figure it out that way. So to figure out the midpoint, if I was going to do it for this side, I would count over 1, 2, 3, 4, 5, 6. That's how many I have to go this way. And then up 1, 2, 3, 4, 5, 6. That's how many I have to go up to get from this point to this point. So if that's how much it is for the whole thing, I can just divide those by 2, and that'll get me the midpoint. So instead of over 6, up 6, I'm going to go over 3, up 3. And there's my midpoint. Now, since that's my midpoint, I can make my first median by connecting that with the opposite corner. Cool. All right. For the horizontal side, this is going to be even easier because I can count over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to get from here to here. So if I divide that by 2, instead I'm counting over 1, 2, 3, 4, 5, 6. So there's the midpoint. And then connecting that with the opposite side, we get the median. Now, really, you only have to graph 2 of the medians in order to figure out what the centroid is, because where they intersect is where the third one will also intersect with them. So really, I'm all done. I can count over 4, up 4. That's where my centroid is. So my answer is that the centroid is at 4, 4. So we're all good to go there. If you wanted to, you could find the other midpoint and graph the other median just to make sure. This one you also end up going over 3, up 3 to find that midpoint. And then you can draw it through there, and we see that they all 3 intersect at 4, 4. Okay. I would encourage you to pause the video for a second to try number 6. Number 6 has the coordinates 3, 3, 5, -1, and -2, +1. So pause real quick, graph this one, find that centroid, and then unpause it, and I'll go through it. Okay, so hopefully you paused it. I'm going to start going through this one. First, you got to graph the coordinates 3, 3, 5, -1, -2, 1, and then connect the dots. And now we got to start finding some midpoints and stuff like that. So on this one, I have to go over 2 and down 1, 2, 3, 4. So instead, I would go over 1, down 2, and there's my midpoint. And I'm going to connect that with the opposite side, just like that. And there's my first median. For the next one, I'll do this side. We're going to go over 1, 2, 3, 4, 5, and down 2. Now, if you get an odd number like this, that's okay. 5 divided by 2 is 2.5 or 2.5. So when I count over, I'm going to go over 1, 2, and then halfway. And then 2 divided by 2 is 1. So I'm going to go down 1. And there's my midpoint. And so you're just kind of getting it close to where it's supposed to be, since, I don't have exactly 0.5. But close enough is good enough in this case. And then I draw my median. And we notice that they cross at the coordinates 2, 1. Now, if you want to, you could also find the median of the other side here, or the middle of the other side. In this case, you'd have to go down 1 and over 3.5. And then you would also see that they intersect there as well. All right. So for your homework, again, you're finishing both of these worksheets. So you're going to want to do 15, 16, and 17 on the graph paper back here. Otherwise, that's all we've got for today. Have a good one.